Hello students, this is question from JEE Advanced 2026 and it is a mixed question. It has reaction from all the chapters and question is in the following reaction sequence Q, R, S, T are the major products. You have to find the major products in each reaction and the correct statements about Q, R, S, T is are, and you have to comment on the correct options, which are the correct option. So I will solve the reactions one by one. So first is the Kolbe's electrolysis of 1, 2, 3, 4 butanoic acid. First reaction we have butanoic acid. After its Kolbe's electrolysis, CH3CONA, sodium butanoate. After its Kolbe's electrolysis, we will get it is a free radical dimerization reaction, and radical in this case will be a propyl radical, and by the dimerization of two propyl radicals we get one hexane molecule as the product of first reaction, but we have to solve the second reaction as well. In second reaction we have V2O5 at 500 degrees Celsius and 10 to 20 ATL. So it is a vanadium pentoxide at 500 degrees Celsius and 10 to 20 atm pressure. This is a aromatization reaction. So by the aromatization of this hexane we get benzene. So product of first reaction is benzene, which is Q. So this Q is reacted with anhydrous AlCl3. So next reaction is we have to react this benzene with anhydrous AlCl3 in presence of one anhydride is given. This is a phthalic anhydride. So we have to react benzene with phthalic anhydride in presence of we have phthalic anhydride. You have to react this phthalic anhydride in presence of AlCl3. This is a Friedel-Crafts acylation reaction. So we have to carbocation. Here we will have a carbocation, and after the formation of product, the H is removed and we get one hydrogen here. So we have to do the Friedel-Crafts acetylation. So after Friedel-Crafts acetylation on the benzene, we have benzene and this acyl group will attack here. So we have C double bond O and one benzene ring here and one. This hydrogen is removed by this COO minus will remove one hydrogen from here. So we will have one COOH group here, COOH. So this is the product for second reaction and it is named as R. So this is the product R. And next, in the next reaction, it is treated with PCl5 and followed by H2PD barium sulfate. So if you react this compound with PCl5, so this OH will convert to Cl, and so one by one I will do the reactions one by one. So product for this reaction will be we have one C double bond O. This OH is replaced by Cl and we get acyl chloride group. So this is the product for first reaction, and second reaction we have to treat this acyl chloride with H2PD and barium sulfate. It is a Rosen 1 reduction reaction. We have to treat it with H2PD in presence of barium sulfate. It is a Rosen 1 reaction and it is a partial reduction reaction. So this COCl group will change to aldehyde group, CHO group. So product for this reaction will be, so we have one benzene ring and another benzene ring here, C double bond O. This group is changed to COH aldehyde group. After Rosenmund reduction of this group, we get a aldehyde group here, and this compound is named as S, and it is treated with hydrazine NH2NH2 and heat. If you treat this compound with hydrazine and heat NH2NH2, it is hydrazine and it is also mentioned it is heated. So carbonyl compound reacts with hydrazine to give hydroxyl. So we have to just remove. So the normal reaction is for C double bond O, and when it reacts with hydrazine, we get hydrazones. So we have to remove this water molecule. So, but you observe the compound, it has one carbonyl group here and another carbonyl group here. So it has two carbonyl groups and we have two NH2 groups here. So what you have to do? You have to do this reaction. C double bond O, carbonyl group of aldehyde or ketone reacts with hydrazine to give hydrazones. So product will be C double bond N and NH2. Next it will react with another C double bond O group. So the product will be C double bond N single bond N double bond C. So this one carbonyl group, aldehyde group, and this is the another carbonyl group which is a ketone. So you have to react both this group and you have to remove two molecules of water. So product for this final step will be, here I am drawing the product. We have one benzene ring here and on the next carbon C double bond N, and next we have, here we have another carbon and it has single bond N. This will be the product of such two reactions. So one oxygen and these two hydrogen are removed, one oxygen and these two hydrogens are removed, and here we get a double bond N, here we get a double bond N. So between this carbon and this nitrogen we have a one more double bond. On this carbon we have one more benzene ring. I am write a pH for this benzene ring which is bonded to this carbon. So this is the product for final product and it is named as T. This is the T. This is Q is benzene. Next R is this compound and we have S is this and T is this. So first statement is S on warming with S on warming with ammoniacal AgNO3 results in the formation of silver mirror. So definitely this compound has one aldehyde group. So it will give silver mirror taste in presence of ammoniacal silver nitrate AgNO3. This group is oxidized to carboxylic acid group and Ag is reduced to Ag plus is reduced to Ag. So this compound aldehydes gives silver mirror taste. So A option is correct. Next B option is Q on treatment with Cl2 excess UV gives gammaxane. So Q benzene on reaction with chlorine in presence of ultraviolet light. Here all the chlorines gets added to the benzene and we get the product C6H6Cl6, and this compound is named as gammaxane. So this option is also correct. In presence of chlorine and ultraviolet light, it is a reaction from NCERT. We get the C6H6Cl6 gammaxane as the product. So Q on treatment with Cl2 excess and ultraviolet gives gammaxane. B option is also correct. And option C is T is a heterocyclic compound. T is a heterocyclic compound we have these two heteroatoms. Nitrogen atoms are heteroatoms here. So this T is a heterocyclic compound. So option C is also correct. And D option is R on acid catalyzed intramolecular cyclization. R, this is the R compound. R on intramolecular cyclization, acid catalyzed intramolecular cyclization followed by treatment with ZnHgHCl gives 9,10-dihydroxy anthracene. We have to react this R with acid catalyst. So this OH will remove as I will solve the reaction. Here I will solve the reaction. The last option, D option, we have to treat this R compound with acid catalyzed. So this H plus will add here. So we get a water molecule and it is removed as H2O. H2O is the leaving group here and we get the positive charge on. It is a kind of Friedel-Crafts acylation reaction. So this acylation takes place on this carbon. So product for acid catalyzed cyclization will be acid catalyzed cyclization of R. R on treatment with H plus gives a product. This product is formed one benzene ring and we have another benzene ring here, C double bond O, and this COOH group here we will have a CO bond and this will be the product for acid catalyzed intramolecular cyclization followed by treatment with ZnHgHCl. ZnHgHCl. So this is Clemmensen reduction. Clemmensen reduction of carbonyl group gives CH2 group, methylene group. So we will have product as we have to convert these carbonyl groups to CH2, one CH2 here, another CH2 here. So product of the reaction will be, this will be the final product for the D reaction. Reaction in the D option, R on acid catalyzed intramolecular cyclization followed by treatment with ZnHgHCl gives 9,10-dihydroxy anthracene. There is no hydroxy group in this compound. So this option is totally wrong. If you do the numbering, it is 1, 2, 3, 4, 5, 6, 7, 8 and we have 9th and 10th carbon here. So there is no hydroxy group on 9th or 10th carbon. If you treat this compound with NaBH4, then it can form 9, 10. It will not give anyway, it will not give anthracene because anthracene have full conjugation in on the 3 rings. So this product is not 9, 10. It do not have hydroxy group. So D option is totally wrong. So correct options are A, B and C. So final answer for this question will be A, B and C. That's it. Thank you.